Hello, everyone. So, as we kick off our journey into Android development land, I thought I'd just give you a brief history of mobile, at least the highlights, and an introduction to Android itself and some of the main concepts of it, and just kind of situate, all this mobile development stuff in the larger world. And this will also kick off our first laboratory experience from your book. Okay, so hopefully you've got your book either close at hand or well on its way. And after this video, you'll be ready to tear into lab number one. All right. So let's get going. Mobile phones, right? So you all have no doubt been driving along and seen these things around. Well, this is a cell phone tower. Not very pretty, is it? Though there are some that look more just like poles and some that crazy people dress up to try and look like trees, but they look more like Lego trees and it never quite works out. But anyway, this is a cell phone tower, right? They're kind of littered all over the place. They're more dense in metropolitan areas. And if you get out into the deep country of Montana, you might only see one every 10 miles or so, or further even. But that's what it is. It's a cell phone tower. It's a mobile phone tower. And when you've got one of these little beasties here, it's got a radio in it, and it is communicating with this little guy, or this big guy. You'll see these things are 100 feet tall, 150 feet tall or so. And, it's radio communication, just talking back and forth, just like the radio that's in your car, and at a different frequency, right? Different bandwidth. So that's it. They're talking to him, and then these guys are talking to some sort of base station somewhere nearby, like the AT&T station or the Verizon station, and that station's probably beaming it up to satellite and wherever else it needs to go. Okay, so that's a cell phone tower. Now, why in the world are they called cellular phones? Well, if you look at the way that we used to think about cell phone coverage was you had these really ugly towers sticking up here and there, and each one of them comprised a cell of coverage that kind of, resembled a honeycomb or now, in truth, it's not that neat and clean. In fact, the cells look more like this. They're irregular and they overlap in places. But nonetheless, each mobile tower serves a cell of area that it provides support to, right? And so your phone knows which tower it is currently communicating with. And in general, it's going to communicate with the one that is closest, the one that serves, your carrier, if it's AT&T versus Verizon, when it has a choice. Sometimes it doesn't have a choice. Sometimes it's just attached to the only one in the area. But it knows which ones it's attached to. And by the way, the phone company knows which tower your phone is attached to. And that's why you hear in all these crime drama stories about how they know where you were based on your cell phone location, which is actually, in fact, not always reliable. But anyway, these cells might be a kilometer wide, they might be 5 kilometers wide, they might be 10 kilometers wide. It just depends. Again, if you're in the metro area, they're going to be more densely packed because they can each service only so many radio connections at one time. So you got to have more people there. It's also why when there's a power outage and the phones go down, cell phones stop working. It's not necessarily that the cell tower is inoperative, it's that it's flooded, right? And it just can't handle any more people, so it's really, really slow. All right, but anyway, now you know why they're called cell phones. It's because of the area that a particular mobile tower operates. Well, let's talk about mobile phones, okay? So here is the very first mobile phone. This guy is named Martin Cooper, and he worked at Motorola, right? Big cell phone company. And the name of this phone is the Dynatac. It was first kind of revealed in April of 1973 at the low, low weight of 4.4 pounds. So this is carrying around a very heavy book or a very small dog, um, but it was a mobile phone, right? It was attached by radio to a particular station not too far away and was the first kind of like phone device, right? We had walkie-talkies and radios and things like that for the Army before this, but this was for commercial. It had a number. You could dial another landline from this device and talk to someone who's connected to a landline from a device, this mobile phone that wasn't connected to anything at all. Um, it was finally released. It was in research for a long time. It was finally released in 1984, and you could buy one for a mere $4,000, and that's in 1984 dollars. Um, so like 1/9 of a Bitcoin. It took a mere 10 and a half hours to charge. And if you were lucky, you could talk on it for a whopping 30 minutes before you completely drained the battery. It did, in fact, have an LED display, which was kind of neat. But anyway, here's the first one. So somebody asks you how old are cell phones? You say 1973, older than Dr. Lehman, in fact. So these things are, I guess it's 2020 now, they're coming up on their 50-year anniversary. So congratulations to cell phones. And think how far we've come from these big beasts, right? For a long time, mobile phones, they started out big and the goal was just to keep shrinking them and shrinking them and shrinking them and shrinking them. And eventually we started to add some function to them. Things like text messaging and things like having a contact list. But for a long time, that's all that phones did. They talked, they texted, and maybe they told you the time and had voicemail. That was it, right? It was primarily a communication device. But then things changed. In the 90s, we started to have these separate devices. And this is, as you can see, the Palm Pilot. Right? And what were these devices called? They were called PDAs, Personal Digital Assistants. And they could do more stuff. They could do things. They were meant to be the administrative assistant in a pocket, right? You had to-do lists, you had contacts, you could pull up a calculator, you could store some files on there. You could do all sorts of things. Some of them you could plug into a phone. You could do all sorts of things with them. They had touch screens, which was pretty cool, though they weren't great touch screens. You could draw on them. Neat little thing, right? Two separate mobile devices that kind of did something separate. But then people were like, well, can we combine these concepts? Can we make the phone, which is primarily a communication device, do more of this business organization stuff? And so this is the very first smartphone, okay? This is the IBM or Simon. It ran on the Bell South network, and it could do pretty cool stuff. It could make cellular calls because we have a bunch of mobile device cell phones now. It could do this weird new thing. This is 1994. It could do this weird new thing called email. It could send a fax. And it had some other things. It had a calculator and contact lists and things like that. And of course, you'll notice if you squint real hard at it, it has a touch screen. Right? So way back in 1994, we had a touch screen. Pretty cool stuff, right? And so the Simon is really the first instance of what we would call today the smartphone. And now, pretty much today, every phone is a smartphone. So what in the world is a smartphone? What makes a smartphone smart? Smartphones are handheld general purpose computers. Now, being general purpose, what that means is that they can run any app, right? They're built to run apps that are programmed by people. So not just little things hard-coded like calculators and contact lists, but like, hey, think of this thing not as a phone, but think of it as a computer, like a Windows computer or a Mac computer that can run all sorts of programs, but this one you can actually fit in your hand. Right? That's a smartphone. Okay, so smartphones have an operating system, just like Windows or Mac OS or Linux. they have an operating system that kind of manages programs and interfaces with the hardware. It provides this interesting layer between the app and the hardware below it. So when you hear the term app, which is of course short for application, what we're talking about specifically is a program that runs on a smartphone. Just like you write Python programs that run on Windows or Mac, depending on what you have, an app is very simply a program that runs on a smartphone. Okay, so quiz. What was the first commercially successful smartphone? Well, if you flip ahead in the slides, you'll know that the answer is not, in fact, the iPhone. It is the BlackBerry, right? BlackBerry's still out there, still hanging around. But for a long time, these were very widespread. They have their own proprietary operating system. They don't run Windows or Mac or Android or iOS, anything like that. They run BlackBerry. I forget what theirs is called off the top of my head. But the thing about them was they were slick. They were sleek, right? They could be small, they could be large, and they had a full keyboard on them, right? So BlackBerry really took off. RIM is the parent company. They're a Canadian company. And they've been around since, early 2000s, I would say, is when they really took off. But of course, when you hear smartphone, the thing you really think about is this, the iPhone. So this is a rendering of the very first iPhone from 2007. And, there were Apple fanatics back then, but the thing about the iPhone that was really special was what? Well, what's missing on this picture that wasn't here, but on this picture? Okay. That's right. This is the first phone that was commercially successful that had a touch display. And not only was it a touch display, it was multi-capacitive touch display. What does multi-capacitive mean? It means that you could put more than one finger on it at a time, right? So if you think about things we take for granted, like pinching and panning and zooming and twisting with like two fingers, scrolling up and down, that didn't happen before the iPhone, right? At least not in a mass market kind of way. So that was nice. Why? Because it let you get rid of the keyboard. So now you've got still a relatively small device, but you don't have to sacrifice half of the screen for the keyboard. Instead, the screen was the keyboard. So that was kind of cool. And right, the world is forever changed since the iPhone came out. Basically, every device now is a smartphone with one of these multi-capacitive touch displays. All the Androids. You can still get some with the typing with the regular haptic keys, but mostly things look like this nowadays. All right, let's switch over. Let's talk about Android very quickly, just so you know the basics of what Android is. Android was originally an operating system for digital cameras way back in the day. And in 2005, they were bought by Google, and Google wanted them to be an operating system for their phone. They knew that well, not their phone, but for phones, because they knew Apple's working on this. There's this big market for general purpose smartphones. BlackBerry had shown that it would work. So Google wanted to get in the game somewhat presciently. Google was not a gigantor company at this point. I mean, they were still big, but they're not the behemoth that they are now, right? So they bought Android. They launched the official Android operating system in 2007. Google was also getting into the smart book, little Chromebook market for small laptops, small cheap laptops. They're getting into the tablet market. And then in 2008, the first commercial Android device was launched. It is the HTC Dream or the T-Mobile G1 here in the US, right? So Android today, though, right, Google produces a handful of Android devices. The Pixel devices come from Google. But far and away, though, most cell phones on the planet run Android. So Google said, you know what? It's free. You all can do what you want with it. They made Android open source. And Unlike iOS, Apple's operating system, you can develop for it for free. You don't need a Mac to run it. Android, you can write Android code no matter who you are, right? And Google very presciently said, yeah, if we give away this operating system, we can actually learn a lot about the people who are using this operating system and the devices and things like that. And, that's how Google makes its money, right? By knowing things. So they basically give away Android, and now Android is everywhere. There are about 3 million Google Play apps right now, 3 million apps that you can download for Google. Several thousand of them are fake, malicious things to just skim your data. I don't lump Instagram and Facebook in that, though they are malicious. Since April of 2017, Android is the most popular operating system used to access the internet. More than 2 billion active users. So think about that. Most people get on the internet using Android, not Windows, not Mac, not iOS, but Android. And it's not even close. Okay? So this class, as we know, as I've said, it's called Mobile Applications Development, but we are going to be using Android. Why? Because it's free, because you don't need a Mac to develop it. To develop iOS, you have to have a Macintosh computer to do that, and we just simply don't have enough to use, whereas Android will run on anything. Android is Java and Linux-based, so the Android operating system is Linux-based. iOS is Swift programming language with a minified Mac operating system. And you can see here the market share is, over 80% of smartphones run run Android. The rest mostly run iOS, right? So it's not even close when you compare market share here, simply because iOS is locked down by Apple, and iPhones are expensive. There are lots of cheap Android phones. All iPhones are expensive. All right. So if you want to develop an Android app, you're in luck. You need nothing actually, because Android will run on any phone, or excuse me, you can develop Android development code for using any operating system, and Android comes with an emulator, a little fake phone that will run on your desktop, and you will become intimately familiar with it, that you can develop your app on. Swift, iOS, you need to make iPhone apps, you need an Apple, you need a Mac. And there are some platforms for developing for both, having a single code base that kind of gets translated into Android and iOS. We don't go into them in this particular class. Whew. All right, let's wrap up here. So let's just start out with some vocabulary. This is stuff that you are going to learn in your very first lab that goes through chapter 1 of your book, where in fact you will be building a very primitive app that runs in the emulator. There are 2 major components in Android apps, vernacular you need to learn. The first is activities. Okay, activities define what the app does. Each activity is captured in a Java class, and it's got code in it, Java code that like reacts to things the user does, like pushing buttons or typing in something. And that's where the code lives that computes stuff. Okay, it's a Java class. And usually an activity is usually, if you're using an app, it corresponds to like one screen on the app. So like here's the Spotify, this is a playlist with some controls on it. This is one activity. If I were to tap, say, the name of this song here, and it would bring up song details on like a new screen, that would be a different activity. Okay, so activities define what the app does, and they roughly correspond to one screen on the app, and each activity is like specified using one Java class per activity. The other major component are the layouts. Okay, the layouts define the user interface. Okay, so this is going to be a little bit different from probably any sort of development you've done before. We've got activity Java code, which kind of computes, processes, and does stuff. And then you've got layouts, which are these other things in XML files that specify the way the screens look. That's their job, okay? This shuffle button goes here, and it's green, and it's got rounded edges, and it's got this text, and then we've got some text here, and a little switch, and then a list. All of this stuff, all of these different things that you see are called views. That's just the Android term for them. They're views. You might call them widgets. Just stuff that appears on the screen, but it's like a thing, right? This button is a thing. This text is a thing. This slider is a thing. This button is a thing. This icon is a thing. These are different views, different widgets. And what the layout file does is it says, okay, I want my widget to look like this. I want it to go, and I want it to go in this place on the screen. Okay. The other thing the layout will do is it will connect a widget. Say, when I click the shuffle button, what should happen? The layout will say, all right, when you click the shuffle button, go over here to the activity code, to the Java class, and run this code. That's event-driven programming. Okay. We're going to get into all that, but kind of keep these things in mind. Activities are one screen, usually. It has a Java class, and it does the computing. It does the coding. The layout, each activity also has an associated layout file. The layout says, here's how the screen looks, okay, and how it's organized. All right. Android itself is very sophisticated, right? You're going to be writing code. I mentioned in the previous video that the Android development kit is, couple gigabytes worth of information. That's because Android itself is, it's a whole computer that you're going to be putting on either your phone or a fake phone, more like, to deal with different things, right? So you write applications at the top level, and those applications kind of communicate with Android's libraries, and Android's libraries communicate with the operating layer, with the virtual machine layer, and then there's all this stuff, right? So the main thing to bear in mind, and you will come to experience this, some of you much to your chagrin, is that when you're writing Android code, there's going to be a whole lot going on under the hood. Stuff you never see, stuff you don't want to see, but just one little line of Java that calls one little Android library function is actually a horrifically sophisticated thing, that stack of things that goes on to make your app interface with the microphone, to display something on a physical screen. It's interesting stuff. We're not going to dive too deep into it, but just know that there's a lot going on when you write an app. Stuff you don't have to concern yourself with, but there's a lot going on. Okay? The tool that we will use is called Android Studio. Okay, this is what it looks like. If you used PyCharm, maybe in your data structures class, or if you used IntelliJ in your object-oriented class, you have seen this IDE. Android Studio is an extension of the IntelliJ IDE. So you're going to be writing Java code. We're going to get into it. We're going to get familiar with it. It's the only way to write Android code. Okay, so this is a tool that you will need to download, and your first lab will get you going with that. Okay, but this is going to be your life in this class. You will be working nonstop in this tool, Android Studio. Okay. Android Studio is an integrated development environment, just like PyCharm, IntelliJ, Eclipse. That's your tool. Now, complementing Android Studio, which is your development tool, is the Android Software Development Kit, or SDK. It is all the libraries, the Java code, the other tools that you need to build, run, compile, and deploy Android apps to a phone. Okay, so these are two things that you will wind up downloading and setting up on your computer. Android uses this thing called Gradle to build and download libraries for you. Okay, we will see this in labs. there's a whole lot of stuff that people have published out there in the world to make Android development life better. Um, Android uses a tool called Gradle to kind of automatically download these things and weave them into your app. Very handy. Also very professional, right? When you go out to the real world to do real development, you use things like Gradle and other comparable tools to kind of manage all the dependencies that are folded into your project. Okay, one little thing that's being cut off by my head here is that you will frequently see this little warning as you're using Android Studio. Um, Keep Android Studio up to date. If it tells you you need to update, update. Okay. Android is a very active, very lively project. It is constantly being updated with performance improvements. You will find that Android Studio and Android SDK are resource hogs. They will turn your computers into a space heater. Okay. Um, Keeping these things up to date, just click the little update button when it pops up. Um, can help improve performance, stability, all sorts of things. Okay, so keep this stuff up to date. All right, now, kind of wrapping up here. I know I've been talking a lot this week. Usually I won't talk this much, I promise. It's time to get you started. So if you go to today's module on Canvas, you have some homework to do. Yeah, and it might take you just a little while, okay? But we gotta start strong so we can finish strong. And I think it's gonna be fun, right? This is fun stuff. This isn't boring crap. This is gonna be a fun course. Um, Go to today's module on Canvas, read the syllabus. Very important, read this page titled How to Do This Course. Complete a survey for me, please, and then do the lab that's provided there. This is going to get you set up to develop Android applications. It's going to get all the software and code that you need on your machine. And, come to me. If you run into any problems in this process, come to me. Downloading and installing this stuff takes some time. Okay, it's just big stuff and it takes a while to install. So do that. Read the preface of your book, and then do the lab. The lab is based on chapter 1 of your book. So if you don't have your book in hand yet, get it. You don't want to get behind, right? Don't start off that way. That's it. All right. So I will talk to you next time, and please reach out to me on Slack with any questions you may have. Good luck, and I hope you have a great semester.